Good morning, good afternoon, everyone. My name is Isaak Tecle. In this presentation, I will share with you the statistical analysis and breeding decision support tools in CassavaBase. In the coming few minutes, I will highlight tools you can use to explore or assess your data and perform predictions and inferential statistical analysis. I will also highlight some tools that can make your breeding decision a little easier. In the process, I will also try to make an impression of the data visualization in the database that you can use to make sense of your data. So obviously, many of the analysis tools I will share with you are familiar to you, or you do the same analysis in your laptops. So the question is why do the same analysis in CassavaBase? One is you are likely to gain efficiency, and this is because in CassavaBase, the analysis pipeline is well integrated and automated. It takes few clicks to just do from data retrieval, data pre-processing before the analysis, doing the analysis, and saving the analysis into the database. Second is because CassavaBase implements standard algorithms and methods for the analysis, regardless who does the analysis, when or from where, you are likely to get the same results. Third, you can easily store intermediate or final results from your analysis into the database, which you can use later for your own, or just share it with your colleagues. So what kind of exploratory data analysis can you do? Well, to start with, you can do descriptive statistics, and you can do this immediate to uploading your data into the database. You go to the trial detail page, and you can just have a glimpse of what your data looks like. You can look at the minimums, maximum values for a trait, can look at the mean values, etc. You can check if there are any missing data points, and so on. You can also check at the spread of the data using a histogram. And using the histogram, you can see if there are any outliers. You can just evaluate what clones might be performing better than what clones. If you want to know what traits are related with each other or what kind of relationship they have, so you can focus on certain traits for your analysis or selections, or just to have an idea what selecting for one trait means to another trait. You can do correlation analysis, and the correlation analysis will generate a heat map for you. And by pointing at any pair of traits, you can see the relationship, its magnitude and direction. If you have data from multiple environments in terms of locations or years, and you want to compare how the data looks like across years or locations, you can use a trials comparison tool, and it will generate the scatter plots and histograms for you to get a sense of what the data looks like across environmental conditions. If you want to assess any underlying patterns or similarities in a group of clones, for example, based on any kind of measurements taken on them, whether it is phenotypic or genotypic measurements, you can use PCA, and it will show you if there is any underlying pattern. For example, applying a PCA analysis on this mock data set that is made of clones from NACRI and IITA shows that, yeah, there is some differentiation between the clones from the two breeding programs. If you want to examine in more detailed way what kind of underlying similarities or subgroupings there are in a set of clones, you can also use hierarchical clustering. For example, here I'm showing an output from one analysis that was done in a population composed of clones, again from NACRI and IITA, and it shows that the IITA clones are clustering into one group, and the clones from NACRI are clustering into another one. And of course, within each big clusters, there are also subclusters. So you can do this kind of analysis and use it in your downstream analysis, or just have an idea of in what kind, with what kind of material you are working. If you want to create just any number of subgroups, or if you want to segment your data into any number of groups based on phenotypic data measurements or genotype data, or even GEBVs, you can also use k-means clustering. And the tool generates a plot for you with the different groups colored differently. And there are many outputs, of course, you can download and check. If you want to check what kind of relationship there is between pairs of clones, or if there is any inbreeding in your clones, you can also use the kinship and breeding analysis tool. With this tool, again, you generate a heat map showing the degree and direction of the relationship between the clones and the level of inbreeding in the clones. So moving on, of course, you can do ANOVA. You can do ANOVA on single trial data, and doing that will generate you ANOVA table, the adjusted means, and also there are diagnostic plots you can use to assess the ANOVA model. If you have data from multi-environments, you want to assess G-by interactions, there is also a tool for that that implements AMI and GG by plot approach, and you can get the stability of your clones across the environments using this tool. If you just want to predict or estimate blobs or blues by fitting your own custom mixed models, you can also do that. There is a tool that allows you to fit factors as fixed or random effects in the model. And also you can use this, you can use the same tool to add interaction terms into your model. In any case, you can estimate your blues or blobs using this tool. If you do that on multiple traits and you want to calculate selection index, there is also a tool for that. This tool, selection index calculator, allows you to give any relative weights to your traits and calculate the index. A genomic prediction tool for that, it is called SolJS. And with this genomic prediction tool, you can create training data sets, fit prediction models, and use the prediction models to estimate or predict GBVs on your selection candidates. Besides that, the tool has many integrated features that can make the workflow easier. For example, there is a feature to evaluate how the GBVs correlate with the phenotypes. There is a histogram plot you can use to evaluate the spread of the GBVs. You can check at any end of the histogram to know what clones are performing best, what clones are performing worst. There is a way just from here to store the GBVs into the database. If you want to check the expected genetic gain, there is also an interface to generate box plots. If you do predictions on multiple traits, there is also an integrated selection index tool that allows you to assign any relative weights to your traits and calculate the index. If you are using GWAS in your breeding program, there is also SolGWAS. With this tool, of course, you can do the standard GWAS analysis and generate Manhattan plots, including diagnostic plots like QQ-plot. So to wrap up, in CassavaBase, there are many tools you can use to explore your data, gain insight into your data in the database. And also there are tools that you can use to do predictions and inferential statistics. And doing all those analysis in the database is likely to improve your efficiency and also maintain data integrity. All those tools I showed you are available in all the breed-based instances. So you can explore them in your databases. If you just want to explore the tools, just get some practice on them, you can go to CassavaBase and find them, I think most of them in the Analyze menu. And thank you for your attention.